Hello guys, this is Frank with HVAC Life. The company that I'm currently working for, they do a lot of maintenances, especially during the winter time, due to the fact that we're slow, and everybody who works in HVAC knows that we tend to be slow during winter season. So this company that I currently work for, they rely on maintenances whenever we slow down. We do get service calls here and there, but mainly we do maintenance during wintertime. Summertime, we do a whole lot of service calls. We'll be a whole day and all, we'll be doing service, diagnostics, all that. This morning I had to do a follow-up because one of my coworkers was doing a tune-up. The homeowner just bought a brand new home and just wanted to inspect the whole entire system for safety and reliability. So he checked the furnace, checked the whole entire system, but he couldn't check that ductwork due to the fact that it was in a crawl space and he couldn't quite fit underneath the house. So they ended up sending me there today to check the ductwork. The ductwork is made out of metal, it's KD. So the problem was that the ductwork, the pipe itself, was in decent shape, you would say. But the insulation, the outer barrier, was peeling off, and there's a section of flex that was attacked by rodents. So I don't know. I provided him with enough options to see if he wants to repair some of the sections that's damaged, or he wants to go ahead and move forward with replacing the whole entire ductwork. The problem is that the reason why they install metal pipe underneath the house is because they could have rodent issues later on, or rodents get underneath the house and they start chewing through the flex. I'm not sure how they can shoot through the flex, because the newer flex, for example, they have the fabric around of it that could, it's pretty hard. So, but either way, so they can either take the risk of installing flex duct, or they could install aluminum flex. Those are the only two options. The problem is that aluminum flex is quite expensive, so that's something they really got to think about and see what they want to go ahead and do. Right now I'm on my way to do a routine maintenance, just regular checking the system and making sure everything's working and there's no safety concerns regarding the system. So I will see you when we get there. Okay, so this is the system that we're working with today. It's a Lennox furnace with 80%er. One of the issues that I noticed while I was here was this. See this wires exposed right there? So they take power from here because this is a RV home, and they went in there. For some reason, it seems like they cut it in short, or the sleeve just fell down. Alright, so, but this is gonna be the system that gonna be performing maintenance today. Another problem that we have is all these plants are on the way for me to be able to reach the system properly. So I'm gonna go ahead and move some of these plants out of the way if I can, so I can be more comfortable working in the system. Right, so it seems like that plant right there does not want to move because the roots go in there somewhere. So I try to move it out of the way, but it doesn't seem like I want to move, and I don't want to damage the plant. Alright, so we're gonna start with this. See what we can do here. We're gonna start by removing the screw out of here. And taking a look at this. Looks like the system is running just fine. Not sure what's the wet spot right there. Now where's it coming? Okay. Seems to be working. I'm gonna grab my voltmeter. We're gonna begin by checking the amps of the inducer motor. I don't think that's correct. Okay, that's way better. 1.24 amps. I don't understand why this unit decided just to leave the balance wheel on the motor and just leave exposed wires around that. I feel like that's like a safety hazard. I'm not sure why they do that, but I'm not an engineer, so. Okay, so there definitely was like an exhaust leak. It's constantly an exhaust leak around that area, right? You can see the trays coming down from there. Okay, so 1.2 amps. I'm trying to figure out what's the max amperage that this thing can take. Or should be consuming. It's about 1.2 amps FLA. So it's definitely working a full load right now. Oop, almost fall there. There's a lot of things in the way. There's only so many things I can do to stay out of the way. Okay, so next thing we're gonna check is gonna be the whole power, the whole entire power of the whole system as a whole. Alright, so we're pulling about 3.9 amps, the whole entire system. Close to 4 amps. Nothing too crazy. And it seemed like it reached the top. I guess we're gonna wait and see. It's not displaying an error code, so I'm thinking I would reach temp. Pretty sure the homeowner turned the system on as soon as I get here, or the temperature went down and the thermostat turned on the system. Either way, okay. Next thing we're gonna figure out is how old this system is. In data, don't see a date here when it was built. There's a lot of dust in this area. Let's see, so you see this manifold manufacturing recommended, another one, temperature, price. So this thing cannot go over 180 degrees on the supply side, right? And over here, we're gonna see where it says that the temperature rise can only be between 30 and 60 degrees. I'm not sure if you guys can see that, 36 degrees. So what happened is that if the system temperature rise or temperature split is below 30, that means it's underperforming, And if it's above 60, that means it's overperforming. Underperforming and overperforming temperature. Okay, so next thing I'm gonna do, I'm gonna open the blower compartment on. The system already cooled down the heat exchanger. So I'm gonna open this up and check the electronics, the blower and electronics, to see how everything looks. Stay put. Alright, so this is gonna be a 1/4 inch screw. And interesting. Okay, so this is the blower compartment. This is the circuit board, the control board that controls the whole entire system. It gets the signal from here, from the thermostat. The board makes all the sequence, creates the sequence of operation by turning the inducer on and doing what it's supposed to do. Then the inducer comes on, creates a negative pressure, closes these two connections over here, then sends it back to the board where the board knows, hey, now we have good exhaust. Then it turns the igniter on, a hot surface igniter in this case. And then after the hot surface igniter kicks in, the system turns on the gas and we have fired combustion. Oh, we have combustion. Okay. So let's take a pic of what the blower looks like. Let's take my camera, my phone here, and take a picture to see how everything's looking. Sometimes I can take some pretty good pictures. Sometimes I don't take pretty good pictures. So the blower motor seems okay. I don't see any oil leaks. The blower wheel does seem like it has a lot of dust and debris. I'm not sure what that is. This is some type of pollen or something in there. Okie dokie. So besides efficiency related issues, I don't see any major concerns regarding the system operation or any safety hazard besides this leak right here, obviously. But I don't really see any safety concerns. Let me take a look at this filter real quick. Open this guy out. Yeah, the filter needs to be changed. Yeah, it needs to be changed. It's time for it to be changed. For now, I'm gonna put it back in there, and I'll ask the homeowner if she has an extra filter for this system. Before that, let me take a picture. This area right here, or town plenum, or whatever this is. Okay. Okay, so now we're gonna remove the flame sensor. But before we go any further, we can just disconnect power from the system. Now the power is off. I'm gonna take this guy out and take a look at it. See what it looks like. So this is the flame sensor. I don't see anything affecting it right now. Definitely some marks with a fire. It's been making contact with it, but I don't see any decayed. All right, so what we're gonna do, we're just gonna clean it and put it back on there. All right, so and clean this flame sensor out with a dollar bill, so it's nice and shiny. We're gonna put it back in here, right here. And forgot the screw. There's the screw. Disconnect this white and red cable back in here. Okay, now let's take a look at the igniter. The igniter is way back here. Right there. Let me pull this little guy out of here. Take a look at it. Oh. Well, it seems like the white marks are present. Seems like. Let me show you this closer. See this right there? So usually when we start seeing white marks around this area, that's usually when it's near the end, and that's exactly where it's gonna fail. But it hasn't failed yet. I would still recommend a brand new igniter. It's a homeowner decision what they want to do. But I will add it to my list. Okay, for now, there's nothing we can do with this guy, so we're gonna put it back in here. Well, this is not a 90% furnace, this is a 80% furnace. So that means that usually we won't see a whole lot of corrosion in the burners. But we're still gonna take a look at it, see how they're looking. Okay, so we're gonna plug this guy back over here. And see how we're gonna be able to take a look at this furnace. This door just keeps closing on me. I need something to hold it in place. Oh, there's nothing in this. Oh, look, there's a stick right here. Just gonna use this stick. We're gonna put it right here. There we go, see? I'm a genius. Alright, so let's figure out how we're gonna take a look at these burners. These burners specifically are a pain in the ass. So we're gonna have to take this whole thing off, and you know what? I wonder if a mirror will go deep in there so that way I can take a better look at it without taking this whole assembly off. All right, then you can take a good look at it from there. I don't see corrosion. There's definitely debris from combustion. Well, not a full combustion, but I don't see any major concern as right now. Gotta take a picture of this. Yeah, so we take a lot of pictures every time we come and do a maintenance, so that way we can have proof of anything that we mention that will have to be taken care of. We can have proof. Okie dokie. I mean, they're not terrible. They're not great, but they're not terrible. There's not anything that I can see that could cause a malfunction or for the system not to fire it up. Next thing I want to take a look at is this board. The reason why we want to take a look at the board is because over time the solder joints in the back, they tend to fail. And what happened one day you wake up and you realize that your system is not firing up. And why it's not firing up? Because, well, all the things, but most of the time it could due to these solder joints right here. This is the connection that goes to the igniter, right? So one black and one white goes to the igniter, and the other one goes to the inducer, right? So this is this connection right here. So if this connections fail, like you can see right here, they're starting to fail. It won't make proper connection with the board, so that by that, the board won't be able to get a good connection to be able to ignite the igniter or the inducer. So that's the reason why we like to take a look at the board. So if we can see any of these signs, we can recommend the homeowner a new board, or just in case it fails and the homeowner be like, oh, well, you didn't tell me anything about that. Yes, we did. Yes, we did. So we're gonna put this board back on here very safely, just like that. So that now that that's connected, we know that the board is failing. The next thing we're gonna do is we're gonna perform a leak search, a gas leak search. Okay, so I have two leak detectors. This is my favorite one because I can just drop it in my bag and have it with me at all times. I have a more fancy one, or Versica. Hi. Okay, so this is the one that I like to use. Okay, so the problem with this one is that here's the sniffer. Right, so here's the sensor where it detects gas leaks. The other one that I have, it has a long hose and it's kind of more concentrated where the leak is, and I feel like it's a little bit more sensitive. But this one, I usually tend to create like a shield around of it, so that way I can guide whatever gas leak is coming towards the sensor, so that way it can detect the gas leak. One of the main things I like to check is this gas valves. They tend to leak out of the bottom plate. There's a plate at the bottom. Let me show you. I don't know if you can almost see it right there, but that plate. So in between the plate, there's a gasket. In between, over time, the gasket tends to break and cause leaks. So that's the reason why we check to make sure that there's no leaks at the gas valve. So like I said, we have to take a picture of everything to document everything we do. These gas valves are kind of uncomfortable to be able to check due to the fact that they're facing the orientation. Usually this sensor, it's a little tricky to be able to sense it. Okay, so between all the gasket, there's another gasket in here between the top half where the solenoid is and the bottom half. And we also check that one out to make sure there's no leaks. So these are the screws that we use to check gas pressure. So it will be an incoming gas pressure with the outlet gas pressure. So there's no leaks there. There's no leaks here. There's no leaks there at all either. So this gas valve is pretty good. I don't see no gas leaks. The next thing we want to check is the flex itself. The disconnect flex to see if there's any leaks there. There's nothing. Oh, turn off. You have to reset it. Kind of hard for me to be able to stick my hand in there to shield it. I don't think there's a leak here because I would have smelled it by now. Usually do pretty good when it comes to smell a gas leak or a propane leak. We also do propane up in the hills. This is natural gas. This is a more common area. There's a lot of society here, so it's close to the city enough to where they can run new lines of gas here. But up in the hills, they have propane tanks for those sort of things. Okay, so we already checked the board. We already checked the flame sensor. We already checked the igniter. We check amp ratings for the inducer. I still haven't checked amps rating for the blower itself. We still have to check temperature split to see what the temperature is right now. Put the temperature between what's going inside the unit for what's coming outside the unit. That's what we call a temperature split or temperature rise and heating. I'm gonna get everything. I'm gonna have to step over here and just kind of connect my sensor up there on the supply plenum to be able to check out the temperature rise, and then connect my sensor down here to be able to check the incoming temperature. Give me a minute, I will get this set up and I will get back. Okay, so I'm here back. I already got the sensor connected up there, the supply panel. I also have this 3D printed door switch that I made myself. Try to replicate something that was already created, but I just kind of want to do my own. The one that I bought, the one that they're selling on Amazon is made by Subco. It's about $14. I made this one, and when I went to Home Depot to buy the magnets were more expensive than the one that I could have got online. It didn't make any sense, but at least I was able to create my own. I don't know. So I'm gonna push this in here, and we should be getting power as soon as I connect the system back onto the power. Okie dokie, so I see the LED light is on. So what we're gonna do, we're gonna jump W. I always like to connect the Y one first, due to the fact that if I connect it to the red, and for some reason this end touches something, it can create short. So that's the reason why. Okay, it should be staying on. Usually that's why I carry a vice grip in these units. Some units are fine because this side is flat, so I can use the magnet size to stick it in. But anyway, so what I'm gonna do, I'm gonna connect my vice grips. Okay, I have to loosen them up a little bit. I'll connect my vice grips here just to hold the door switch on. Now that we have power, this is my red right there. And then we should be back in business. Now I can check the amps from the blower motor, as well as temperature rise on the supply side. Okay, so here I got my end. I'll blink and open this thing up. It's gonna take a minute before I can actually reach the temp. So we can see the temperatures rapidly increasing. You just gotta wait for it to reach a certain point and it stays steady at that point, and then that way we can know that's the temperature, that's the maximum temperature the system is operating currently. Alright, so I already checked the amperage. I closed the panel because that's the most accurate way to check amperage on a blower motor. Another thing, I connected it to the Y cable coming from the blower motor to the board, and it's pulling a little way around 3.10 amps. So that's pretty good so far. Okay, so right now with the door panel off is 110. Seems like it's staying steady around 111 degrees Fahrenheit. I don't think it's gonna move any higher than that. So what I'm gonna do, I'm gonna move the sensor from up there down here to be able to compare the incoming temperature to the supply temperature. Right, so I already connected the sensor there. For some reason, I had two sensors and I damaged one during the summertime. Unfortunately, I have to buy another one. They're quite expensive, but I still have to buy another one because moving the sensor from the supply to return is a kind of bit of a pain. So for now, I'm just doing this, but yeah. Alright, so this is the return temperature currently. 62 degrees. So about 58 degrees difference. So about 48 degrees. Remember the numbers that I showed you there? It was 30 to 60. So 40 is 48, somewhere close to the mid-range between those two numbers. So that's pretty good. It's not overheating or nothing crazy or underperforming. So that's pretty good. So what I'm gonna do next, I'm gonna check the gas pressure. So remember, inlet, outlet, right? So I'm gonna check the incoming gas pressure, outputting gas pressure to make sure that it's operating within range. This is only a single stage gas valve, so I'm expecting to see somewhere between 3.4 and 3.5 in the outlet, due to the fact that it's natural gas. If it was propane and it was a single stage gas valve, usually we see around 10 inches of water column of pressure coming through the gas valve and about 13 in the inlet. This is natural gas. We're looking for 3.5, 3.4, somewhere around there. Right, so I informed the homeowner that she needs to get a brand new filter, and she also needs to figure out if she's gonna repair or replace the circuit board now or later. And I explained to her that if she decides to change it later, when it fails, then most likely she will have to wait for shipping and all that stuff, and it's gonna be an inconvenience. So I've informed her that if she wants to change it out, we could place the order. That way they don't have to wait until it completely fails. So she asked me to write down the number, the size of the filter, so that way she can get a new filter from Home Depot. Fortunately, they don't have one right now, but the lack of airflow can affect the heat exchanger and cause heat stress and heat spots where we don't want the heat exchanger to have a breach, something like that. So for now, fortunately my camera died and I was not able to record that I checked the gas pressure and the static pressure of the system. Those are things that we have to check for the system to make sure the system is working as efficiently as possible. and doesn't create all the issues in the long run. I also recommended a blower cleaning. Blower cleaning is recommended due to lack of airflow and many other issues that can happen down the road. So, but yeah, I was getting about 3.41 here at the supply side, and I was getting about 7.32 over here in the inlet. The static pressure was a little low on this side. Sorry guys, so the homeowner approached me. She was questioning about, I guess there's two people that live in this home. They approached me, they asked me what was going on with the board. The good thing is I was able to take it off and show them what was going on with the board. I like to show them to them instead of just saying. I know that we have pictures and all that stuff, but I'd rather show them in person so that way they can actually look at it with their own eyes and kind of get an idea instead of just me showing them pictures. So that's one of the problems. The circuit board, the inducer, I was looking at the pictures before, and I was pulling up on 1.24 amps. So it's definitely, this motor is obviously over amping just quite a bit, or it's working a full load, with that's a lot, it creates a lot of stress. So I mean, to prevent future failure, I would recommend to replace this and replace the inducer motor. This female elderly, so definitely it wouldn't be a great thing just to wake up one morning and figure out that the home is super cold, and that's something nobody wants to deal with. So I'm gonna recommend those two things and the blower cleaning as well. See if they decide to do it. No, actually, I've never seen a threaded 90 installed as a drain like this before. Usually we install a male fitting in here, and then we usually add like a small coupling, a small piece of pipe, and then we add a 90. But I never seen them just connect to 90. Pretty crazy. I like how clean it looks. A little bit of backstory. I used to do install back in the days, so I had the experience of doing install, but I actually never did it like that before. Pretty cool. But right now I'm just gonna put everything back together. So I want to clean all this dust out of the way, and I will see you back in the car. Right, so something else I forgot to mention is that I checked the heat exchanger, and I did notice some heat stress going on. No breach at all, but there's definitely some heat stress. It's pretty normal for a system this age to have heat stress. Even the newer system have heat stress, but I didn't notice anything out of the ordinary. I'm definitely gonna build provide some quotes and estimates to see if they want to go ahead and move forward with any possible repairs. So this Lennox system is about 14 years old, and we start seeing these issues around this time. Usually the warranty is about 10 years because they know that after the 10 years things will start to fail. A lot of people cannot afford the new system nowadays, but all we can do is try to help as much as we can. So I'm gonna do this paperwork, and I will let you know what they decide to do. Right, so I spoke with the homeowner. We ran an application to see if she was gonna be qualified for our financing company that has a promotion about 12 months zero interest, as long as the amount financed is paid in full within the 12 months. So we went through the whole process. I guess the app that I have to do the financing is requesting everybody to take a test. I guess they do this every year. So that took me a little longer to be able to go through the test. So we took the test. She got qualify, so she's able to use the financing team as a credit loan to be able to take care of those issues. Also, let her know that, you know, if you don't take care of this issue, these things can happen. So if for some reason the system doesn't run one day, it's because of these issues. So she knows that. She said, hey, let me get my financial situation together and let me figure out how I'm gonna be able to pay this off before I even go ahead for the loan. And that's totally understandable. I mean, you just don't go ahead and make a decision. You know, you really got to think about it and how you're gonna plan how you're gonna pay it and all this stuff. So that's pretty cool. So call my office, let them know, hey, so this is what happened. I talked to her. She said, let's schedule a day so that way I can call her and see if she decides to move forward with the repairs. We do have a 10-year warranty on whatever we install, whatever component we install. So now it's just a waiting game. But yeah, thanks guys for coming with me in this journey, and we will see each other again in the next call, maybe. Who knows? Bye.